Hey guys, it's Nate here with another data science interview question. This one comes from Twitter. We're gonna solve the question in 4 different ways using 4 different techniques. And then we're gonna discuss the trade-offs, the benefits, the drawbacks between each solution. This is gonna be especially helpful, especially on interviews. All right, so let's get started. But if you like content like this, please subscribe to my channel. Okay, so this question comes from Twitter. It's a medium level question. The question's title is highest salary in department. So the question reads, find the employee with the highest salary per department, output the department name, employee's first name, along with the corresponding salary. All right, so this question is easy enough. It's a medium level question. And like I said, we're gonna solve it in 4 different ways. But before we just jump into the solution, let me break down how I solve any question, whether it's an interview question or it's just a question on my day job. This is my 3-step framework to tackle any question. All right, so the first thing I do is I try to understand the data. All right, so what I'm trying to do is basically understand the data schema here so that I understand and explore the assumptions that I have for the data as well as all of the columns here to better understand how I can approach the solution. So I need to explore the data, or at least ask the interviewer questions about the data and the data structure to understand how I'm gonna solve the question. Number 2 is I'm gonna formulate my approach. And what I mean by that is I'm just gonna write down in words and sentences every step that I'm gonna do in order to solve the question. And this is great, especially on an interview, because what you're doing is you're just breaking down the solution in small little steps, and you're explaining that to the interviewer so that he or she would be able to confirm whether or not you're doing it right or getting it wrong, right? And this is before you've written down any code. So it's really gonna save you time in the long run. Step number 3, code execution. This is when I'm finally starting to write down the code. And I'm basically building out the code in small little steps, just like in part 2, when I basically wrote down each step. I'm basically following that script and just writing down the code. This allows me, if I'm in a high stressful environment, like an interview, this allows me to keep track in terms of what I'm doing. All right, so that's my 3-step approach. Let's apply that to this problem. Okay, so the first step is to understand the data, right? So what we're trying to do is really just understand both the data schema here and then the values in this table. But on an interview, you're probably not gonna be able to actually see the data. So let's first start with just the data schema, the column headers here. This is a table called employee. It looks like we have a lot of columns here. And it looks like it's just employee ID, their name, and some information about that employee, and then their salary, right? So what I'm trying to really do is validate, whether or not this is an employee log. I can obviously ask the interviewer that, but then I'm gonna map the column names and the columns with the question itself. So it looks like I don't need all of these columns here, but what I do need is the employee, their salary, and the department they work in. So I have essentially their name, last name if I want it, the employee's department, and then their salary. So really, I probably only need 3 columns. And what I'm gonna do is just verify that with the interviewer. But because we don't have an interviewer here, let's just take a look at the actual table. So I'm just gonna hit this preview button here. So what we have is a table, first name of the employee, their department they work in, and then the salary that they're making. And this looks like an employee table where it holds, all of the employees that work at a particular company. All right, so that's number 1, understanding the data. All right, so this brings me to step number 2, formulate my approach, which is basically just writing down step by step what I'm gonna do to solve the problem. And in the beginning, in the intro, I mentioned that I'm gonna solve the problem in 4 different ways using 4 different technical techniques, okay? So this is gonna be the first solution. So let's just make this editor bigger here. So let's just call this solution 1, the subquery solution. So if I go back to the question here, what we're trying to find is the employee with the highest salary in each department, right? So we want the department name, the employee's first name and the corresponding salary, which is the highest salary in that department, right? So what's probably going to happen in terms of corner cases and edge cases is that there could be a lot of ties. We could have several employees making the same amount of salary. That salary is the highest in the department, so we could have multiple employees making the highest salary for each department. So we need to build that into our solution. So the first solution, the subquery, is going to be able to handle that edge case. So the first thing we want to do is build the subquery, which is basically a query that will get the department name and then the corresponding highest salary for that department. So we can use the max function here to find the highest salary, and then we'll just group records by the department. So this is relatively simple. And I mentioned before, it's a subquery, so we do need an outer query. So basically we'll have an outer query that will use that subquery to give us the employee's name matching on the department and the highest salary. So the first step is to build a query where we get the department name and the corresponding highest salary using the max function. So here it is. We have this query here where we have the department, the max salary for that department, and we're just gonna be grouping by department. All right, so if I run this code here, what I have are 3 departments and the max salary for each department, the max salary found. All right, and so now the second part of the solution is to write an outer query where we find the employees with matching values of the highest salary found in the subquery. And this subquery is right here. So what does that mean? That means we're gonna write another query where we have the 3 columns, right? And so when you go back to the question says output the department name, employee's first name, along with the corresponding salary. And that's what I have here in this outer query. I have department name, the employee's first name, the salary from the employee table, and we're gonna use the subquery here to basically just find the employees with the highest salary for every department. So where do I want to put that? Where am I going to put the subquery? I'm going to actually put the subquery in a where clause where I match on department and the salary, and I'm basically looking inside the subquery to get me the highest salary, the max salary for every department. All right, so if I run this, what I basically have now is the 3 departments that I saw in the subquery, the same salary values, but now I have the employee's name, employee's first name. So let's just check the solution to see if it's the right solution, and it says that our solution is correct. So the first solution is to write a subquery where we're finding the max salary and then apply it to an outer query in the where clause. So if that makes sense, now let's jump to the second solution. So our second solution is going to be a self-join where we create basically another table to join it onto itself. So let's formulate the approach first. So let's write it out. So the first 3 steps are almost identical to solution 1. We want to define a self-join table with the department names and corresponding highest salaries, just like a subquery, right? So we're going to use the max function to find the highest salary, and then we're going to group records by department. So now the difference is we're going to join that table that we made right in the first 3 steps, join that table to the employee table using the highest salary and the department as keys. So that way when you make the join, what's left is departments with the highest salaries, right? And so what we're going to then do is select the necessary columns that the question asks us to select, which is the first name, the department, and the salary. So this is what it's going to look like. So this is my table here. It's the first 3 steps, right? It's pretty easy. Get the department, get the max salary. I'm just going to call this column max salary, and then I'm going to group by department. This is basically the table I'm going to join to the employee table. So that's relatively easy. So I'm going to just say select star from the employee table, and then I'm going to join using the table that I just created. And so if you read this right here, join the tables using the highest salary and the department as keys, that's what we're going to do. So now we're just going to say as keys on department equals department and then salary that comes from basically this employee table here is going to equal max salary, which is right here. All right. And so I need to add an alias. Forgot to do that. Let's just say A and then A for alias. And then we have this output right here where we essentially have the first name of the employee, their department, so we have 3 departments, and their salaries, right? And the salary is the max salary, is the highest salary in that department because of this table right here. We already have the department, the highest salary in that department. So when we join it to the original employee table, it's basically matching the max salary in that department. So it's really only giving us 3 rows, 3 employees, and 3 salaries. And this is an inner join, so it's just removing everything else. But right now we don't see any ties, right? We have 3 different departments, 3 different employees, as you can see here with their names. So that's solution number 2. So now if I just want to verify this solution, I have the first name, the department, and the salary, and then I'll check the solution, and my solution is correct. And so that is solution number 2. All right, solution number 3, window functions, the good stuff here, right? So now we're getting a little bit more complex in terms of technical concepts. We're going to use the max function for this solution, solution 3. So let's just kind of formulate and write down how we're going to implement a window function to solve this question. So the first thing I want to do is create that window function. I'm going to write a subquery to create an additional column in the employees table that gives me the highest salary for each department. All right, so in order to do that, I'm going to basically write the window function using over and partition by department. And then to finish it off, in the outer query, I'm only going to select the 3 columns I care about, first name, department, and salary, and then I'll filter the results so that the salary equals the highest salary. All right, so let's just now start the code and see what I mean by these steps. All right, so the first step is to use a subquery to create an additional column with the highest salary in the department, in each department. So I have something like this that will create a extra column called max salary that basically corresponds to the highest salary in each department. I'm going to use a window function to actually partition it by the department. So I'm going to finish off this query by just writing over and then partition by the department and then get the max salary for each department and name it as highest salary. All right, so if I run this code here, what I have is basically the entire employees table, as you can see here, but if I go all the way to the right, I see the column that I just created called highest salary, right? So if I actually view the output in a separate browser here, just to give me a little bit more space, again, I have the entire employees table, and then I have the highest salary, and it's the highest salary for each department. So the audit department, the highest salary is $1,100. In management, department management, the highest salary is $250,000, and you can see that Richard here makes that. And so if you remember solution 1 and solution 2, Richard makes the most in the management department here. So this is what the highest salary column is trying to basically do. We're applying a window function to get the max salary, the highest salary for every department. All right, so this is our subquery that we just created, and we need to now write the outer query and only select 3 columns that we care about, and then filter the results so that we're only picking out the highest salary. So this is what it's gonna look like. So these are our 3 columns, department, first name, and salary. And then this is our subquery. And then this is our subquery right here. And all we need to do in this last step is filter the result such that the salary equals the highest salary. So it's where salary is equal to highest salary. So let's run this code here. And again, I get 3 rows, and this is exactly what I'm expecting. And all we need to do now is just check the solution, and our solution is correct. So in this solution, we used a window function here to basically solve the question. All right, so solution number 4, our last solution. We are gonna, again, use a window function, but instead of max, we're gonna use a rank instead. All right, so basically the steps for solution 4 are almost exactly like solution 3. So let me just write this down for you guys. All right, so just like solution 3, we're gonna create a subquery where we have the first name, department name, and salary. And then we're gonna use a window function. We're gonna use the rank function and then add a column with the ranking of salaries in each department. So rank number 1 will be the highest salary in that department. So now that we know rank number 1 is the highest salary, we'll then write an outer query and leave only the rows that rank equals 1. Okay, so let's just implement the first 2 steps here. So what I have is department name, first name, salary, and then this extra column here that is basically implementing a window function and using the rank function. So I have the rank function here over and then partitioning it by the department. And then I'm gonna order the rank by salary in descending order. So the highest salary is gonna be at the top. It's gonna be rank number 1, and the lowest salary for that department is gonna have the lowest rank. All right, so if I just run this to see what the output looks like, what I have are the department, first name, and then the salary in highest order to lowest. So you see in the audit department, 1100 is rank number 1. And then in management, Richard, 250,000, rank number 1. And that's kind of exactly what we've been seeing with all of these solutions here. So I know I'm in the right track. So the last step is to use an outer query where we're only gonna leave the rows where rank is equal to 1. So that's easy. So it's select star from, and then again, this is our subquery right here. And then I'm gonna just filter out all the rows except for when rank equals 1. Let's see what we get. We get the department, the first name, the salaries, and rank equals 1, right? We don't really need rank equals 1 or the rank column in our solution, so I'm just gonna get rid of that asterisk and just put in department, first name, and salary, run it again, and then validate the solution. Our solution is correct, and that is the 4th and final way to solve this interview problem. All right, so now let's talk about all 4 solutions and the trade-offs between each one. So a question you're gonna get from an interviewer is which solution is the best, which one's optimal? And what they're really trying to get at is which one executes the fastest, right? Because you're working with data and you're probably working with large data sets. Depending on how you write the query, it could take, a few seconds, or it could take like minutes or hours to actually execute and churn through that data. So you always want to write code that executes fast. And what the interviewer is really trying to test you for is your technical knowledge of SQL or whatever coding language you decide to code in. So all of the solutions had subqueries. We did solution 1 with a subquery. Solution 2 was a join, but that was basically a subquery. So solution 3 and 4 also had subqueries because we basically wrote a window function where we added an extra column to the employee table, right? So each of these solutions have subqueries. So we can't make the code any faster because we have to execute the subquery before we execute the outer query. So that's the limiting factor there. But in general, window functions like rank over partition by, or the max over partition by department, those are generally faster. There's not a group by clause like you saw in the first solution, and there isn't a join function in the second solution to sort of slow things down a little bit. The window function is slightly faster, but you still do have that subquery there that you can't really get rid of. So in general, what I would say is the window function is probably the fastest, most optimal code. There's really no difference between rank or max, so solution 3 or solution 4. So either one will work. In an interview, it's totally fine to implement any 4 of those solutions. Those are 4 valid solutions. It's just that an interviewer will probably ask you which is the better one. And so it's really nice if you can talk about the technical underpinnings of each function or each solution so that you can basically display that you know SQL theory and you know how to write optimal code. All right, so that's it for me. I hope you enjoyed this video, and if you did, please subscribe to this channel. I go through many different types of data science interview questions, so stick around if you want to learn. All right, thanks. Bye.